grade 9 test that we just took. So here we have two sides and an angle not between them. So we have angle side side, which means possibly could be two triangles. Now if this side is long and this one's short, it could sit in here two ways. So looks like we might have two possible triangles here. All right. Looks like we got an angle and a side cross, and an angle. So this would be law of sines. So and if I want to find y, that angle, the sine of y over the side opposite equals the sine of another angle over the side opposite. And so if I multiply by 4 and then take the sine inverse, I get y equals sine inverse of 7 sine 17 degrees over 4, which is make sure I'm in degrees. Sine inverse of 7 sine 17 degrees divided by 4, 30.77. Now, the other possibility for the angle would be 180 minus this, which is 149.22. (180 minus the 30.77). Okay, now that would be with this side inside here making y a really large angle, and that's still possible with 17 and 149. And that would leave us possible another side for x. So now let's find x. Now in this case, we would get x by doing law of sines again. Now we do trying to find a side, so I'd put x, I'll write it up here, x over the sine of the angle across, and that angle would be, if this was 30 and 17, it'd be 30 and 17 subtracted from 180, so 30.77 plus 17, and that's 47.77 from 180, so that's 132.23 equals 4 a side over the sine of the angle across. So I'd multiply both sides by the sine of that. So I'd change that to a positive angle. Okay, and so I'd take sine of that answer times 4 divided by sine 17, and I get 10.13. Okay, it was the sine of 132.23 degrees times 4 over sine of 17. Now, if the other angle was 149, then to get x, we would have to do x over the sine of what would be left. So if we had 17 and 149, it'd be 180 minus the 149.22 and minus the 17 for the other angle, 13.7. That's when it's in here. This would be just 13.7. So we do the sine of 13.78 equals 4 over sine of 17. And so I'd multiply by the sine of that. So I'd get 4 sine of 13.78 over sine of 17. And the side I would get is 4 sine of 13.78 divided by sine 17, 3.26. So that would go with 149.22 degrees, or the 10.13 would go with the 30.77. And there's two possibilities on that one. Okay, now if we were to use the program's sine law, we had doing this in degrees, and it's angle side side, and enter the angle 17, and the side opposite the 17 is the 4, and the other side is 7, and it tells us the two possible angles are the 30.77 and of 149.22, 23 actually rounded off, but that's close enough. And to get the sides, program cosine law, degrees, and angle side is 3, and the angle was 17, the side opposite was 4, and the adjacent side is 7, and it says the two sides would be 10.13 or 3.26. And that's number 1. Number 2, we have angle side angle and angle and a side between. So angle side angle, which is not one of the ones we have in our calculator, but we can always find the other angle. If we take these two angles and subtract them from 180, we get x. So 180 minus 108 minus 34, 38 degrees. And then we got an angle on the side across, and we can find y. Y would be over sine of 108 equals 213 over the sine of 38. Multiplying by the sine of 108, we get y to equal sine 108 divided times 213 times 213 divided by sine 38, and you get y equal to 329.04. And this one, we have side, 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 and do we need to find the angle? So that would be a law of cosine problem, because that's the only one that deals with three sides, and that says C sum side squared is equal to adjacent one of the sides squared and the other side squared minus 2 times those two sides multiplied cosine of the angle between those two sides and across from this side. And if you solve this for C, we can add this quantity over to here, subtract the C squared, and we get A squared plus B squared minus C squared over 2AB is equal to the cosine of C. And notice C is across from this side. So the side we use here has to be the one across from the angle, 12. The A and B are 7 and 9. So C, the angle C, or X, that we want to find in this one, is going to be cosine inverse, if we take the cosine inverse of both sides, of A squared plus 9 squared, B squared, minus the side across from it squared, 12 squared, over 2 times 7 times 9, and the cosine inverse of that. So I do cosine inverse of, the numerator is 49 plus 81 minus 144. That's the numerator, divided by 60, just go parenthesis 2 times 7 times 9. And that's the whole thing. And we get X has to be 96.38 degrees. And we can check that here. Program cosine law, and 1 because we're doing degrees, and we have side, 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 which is number 2, and opposite side. Notice I have to ask for that one first. And then one of the adjacent sides is 7, the other one is 9, and it says the angle is 96.37. Now, next one. Here we have to figure out the area of triangle in number 2. So number 2 was this one, not this one. So the area, we can get it by doing if we knew all three sides, we could use Heron's formula, but much easier to find the area of a triangle by just doing 1/2 times a side times the side times the sine of the angle between those two sides. These are the two sides I know, and there's the angle between them. So I do 1/2, 1/2 side times the other side times the sine of the angle between those two sides, which is 34. And that comes out to be let's put it over here, 1/2 times 213 times 329.04 sine of the angle between, which was 34. It's 19595.66, and we didn't say how long these sides were, what the units were, so we just call it square units. Okay, page 2. It says find the length from A to B. All right. Well, we only have two angles, so we're going to need to know a side. We can find the third angle too. 35 and 45 added up is 80 from what? 180. It leaves this to be 100. But we need to get a side on this triangle to know how big it is. So we can use this triangle. And notice it doesn't say anything's parallel or anything here, so you can't assume 68s or anything in here. But we got side, angle, side. We should be able to get the side across from it. So the side across is equal to 9 squared plus 10 squared minus 2 times 9 times 10 times the cosine of the angle between. Cosine law. Take the square root of both sides, and so we would be finding the square root of 81 plus 100 minus 2 times 9 is 1880. Cosine 68. And we get this side to be 10.657. Okay, so now I know one side and lots of angles. I got angle, side, angle, but I can use the law of sines. And I need this side up here, AB, so I'll call that X. So X is across from the 45. So X, using the sine law, over the sine of 45 degrees is another side, 10.657 across from the sine of the angle across from it, which is 100. So I multiply by the sine of 45 on both sides, and I get x equals sine 45 times 10.657 divided by sine 100, and I get 7.65. Okay, number 6 says there's a radar station that spots a plane north of its position. So, if the station is north, or the plane is north, generally that's shown up, at a distance of 3 miles, there's one plane. And a second at a distance of 5 miles at an angle 52 degrees east of north. So there's north. We've got to go 52 degrees east of it. It's not 52 on the trig, but 52 east of it. So in here is 52 degrees. And at 5 miles is plane number 2. We're supposed to find out how far apart they are. Now we can't assume that's a right angle, so we can't say that's a 3, 4, 5. It might be close. So let's just find this by using the law of cosines. Find a side when we got side, angle, side. So we do c squared equals 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of the angle between them. Then take the square root of both sides, so we get the square root of 9 plus 25 minus 30 cosine 52, and we get that they are 3.94 miles apart. Close to right triangle, but not quite, because that's not 4, it's 3.94. Okay, now let's do this one. It says a ship is sailing at 7 knots at a heading 22 degrees north of west. So west generally is shown to the left, and so north up here. So if we're going 22 degrees north of the west, 22 degrees, so the ship is sailing something like this, at that direction, and it's going at 7 knots. And now there's a current. It's 1.5 knots in the southerly direction, so the current's pushing it down. So instead of going here, it's going to be drifting this way, so we put the 1.5 here. And we got to figure out this, what's the speed, so how long that is, and the direction. At what angle is this? Some degrees north of west, probably. So, there's no right angle in this, but we do have, we could do side angle side. So using this triangle very well, the only thing we know is if this is 22, this is 22 from 90, 68 degrees here. So that means up here is 68 degrees because they're alternate interior. So I have side angle side, and I could get this side. So side angle side is, you do the square root of adjacent side squared plus the other adjacent side squared. 7 squared is 49, minus 2 times an adjacent side, 1.5, times the other adjacent side, 7, times the cosine of the angle between those, which is 68. And I put something in incorrectly because that's not the right answer. It says I. Let's see here. 1.5 squared plus 49, that's 7 squared, minus 2 times, 1.5, not 15. There's the problem. I missed the point. Okay, and enter, and we get the speed of it, the actual speed is 6.59 knots. Now we'd have to find this angle in here and subtract it off the 22 to figure out what this angle is. So to that, I have a side opposite that angle, and I would choose, and I have side angle side, and I want to find an angle. Oh, I do know. No, I don't know. What do I know? I know I want the one across from this, and I need the angle across from this. Do I know that angle? Nope. But I do have side, 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 so I can find the angle by doing this angle side across from it. So I do the two adjacent sides, 6.59 squared plus 7 squared minus the side opposite, 1.5 squared, over 2 times the two adjacent sides, 6.59 times 7, and do cosine inverse of this. This is like this problem here, where we're using the three sides to find the angle. So I'm doing cosine inverse of the adjacent side, opposite side over the 2 times adjacent side. So that's what I'm doing here. Cosine inverse of an adjacent side, I'm trying to find this angle, minus the 1.5 squared over 2 times these. So typing that in, I have cosine inverse of the numerator, parentheses, 6.59 squared plus 7 squared minus 1.5 squared, that's the numerator, divided by 2 parentheses 2 times 6.59 times 7, close parenthesis for the denominator, close parenthesis for the cosine inverse, and I get the angle in here is 12.19, and I would have to take that off of the 22 to know what's here, so I got to take 22 minus the 12.19, and I get 9.8 degrees. So the ship is sailing at, so my answer now to get this right, 6.59 knots at an angle of 9.8 degrees north of west. 9.8 degrees north of the direction west. There's the answer. Now, the other way to do this one is doing the table that we've done, and so I'm going to go ahead and do that one also. So, if we turn this all into trig, the boat is going 68 more, or 180 minus 22. So the boat is traveling at 7 knots at an angle of 180 minus 22 is 158 degrees. And the current is 1.5 knots at an angle, it's going straight down in trig is 270 degrees. So I'll take and do 7 cosine 158, and I get negative 6.49. I'll do with a sign in there, and I get 2.62 in the I and J directions. Now I do the 15, or 1.5 cosine 270. Really don't need to do this because I know that's going to be 0, and this is straight down, so it's minus 1.5, but just to show you. Okay, add these up, so negative 6.49, and this would be 1.12. So now I convert this back to polar, so I'll do square root of 6.49 squared. I don't have to put the negative in because I'm squaring it. And 1.12 squared. And I get it's moving at 6.59 knots. And to get the angle, I would use tangent inverse of 1.12 divided by negative 6.49, tangent inverse of y over x, and since the x is negative, I need to add 180, and I get an angle of trig of 170, so this is 170.2. So if I want to do it off of this, it'd be that 180 minus that, or yeah, 180 minus that, 180 minus my answer, and it's at 9.8 degrees north of west. Same answer we had up there. Okay? So you got two ways you can do that. This one is a little tricky to make sure you get the triangle drawn correctly. This one, you have to make sure you get the right angles in terms of trig and then convert it back. So they both have a little bit of a challenge to get it correct. Okay, last page. Convert from rectangular coordinates to polar. So that's x and y. So r is equal to the square root of x squared plus y squared. So we get square root of 9 plus 25, which is 5.83, or the square root of 34, the exact value. And then the angle is tangent inverse of y. The angle is tangent inverse of y over x, and plus 180 if x is negative, which it is. So we have to do tangent inverse of 5 divided by negative 3, and then plus 180. And we get 120.121 basically. Next one, we're just supposed to change it to polar, so we want y, which is our sine theta, equals 0.4 x, which is our cosine theta, minus 3. Now some of you solve for r, so I will do that. I would subtract this over, and so I'd have r sine theta minus 0.4 r cosine theta equals negative 3. Factor out an r, and I'd have r times sine theta minus 0.04 cosine theta, and I would divide both sides by that, and I'd have minus 3 over sine theta minus 0.4 cosine theta. And that's something you could type in as the equation, actually look at it. It should be a line, because that's what that is a line. Now this one, x, which is our cosine theta, plus y squared, so that's our sine theta, quantity squared, which means the r is squared and the sine is squared, equals 2. And this would be hard to solve for r because it's a quadratic. If you wanted to solve for r in this, you would have to go r squared with a coefficient of sine squared theta plus a coefficient of cosine theta times r minus 2 equals 0, and then plug this into quadratic formula. And to do that, you would have r equal the opposite of b plus or minus the square root of b squared minus 4 times this times that, so that'd be plus 8 sine squared theta all over 2 sine squared theta. So you'd have to type both of those equations in to actually graph this in polar. The cosine plus this over this, and minus cosine minus this over that. But you didn't have to. All you had to do is convert it to polar. Now, convert the polar to rectangular. So that's r and that's theta. And y is our sine theta, and x is our cosine theta. So all we have to do is take 3 cosine 130, and we get negative 1.93, and then our sine theta, and we get 2.30 rounded off. Okay? And if we want to change the equation, sine theta is not anything but r sine theta is. So if I multiply both sides by r, multiplied by r and multiplied by r, then that's y, and this is, well, if r is the square root of x squared plus y squared, r is x squared plus y squared. And this would be 5, and this would be y. And that's a circle. Anytime you got same number of x squareds and y squareds added, you got a circle. This just moves it somewhere. And that's what this would look like if you type that into graphic and polar. This is harder to solve for y. It would be, again, a quadratic, and you would have to do it like a quadratic formula thing to get solved for y. But I didn't ask you to do that. Number 10. 10, it looks like we're going in and out on a circle of radius 2. So if I have a circle of radius 2, I would say the radius is 2. And it looks like I start in and go out, and then I come back in and out and back in. So the sine would start on the radius and go out and then in and then out. But the cosine could start either out or in, because the cosine always starts with a +1 or -1 if it's a negative. And so we'll just make it a negative, and it's 1 in, so at 1 cosine. Now we need the cosine to make a full cycle. So if it's starting in, goes out and back in, that's a cycle, one full wave in, and we have to get a total of 7 in 2 pi. So the period of this cosine is 1/7. So if I take 2 pi divided by 1/7, I take the normal period divided by the pi period of this is 1/7 of pi, and so the pi's cancel. I'm doing this incorrectly here. I got to get 1/7 of 2 pi, so the 2 pi's cancel, and I get 7 theta. That's what I want to say. The period of this is not here. There's 7 of them in 2 pi, so 2 pi divided by 7 is the period. The normal period divided by the period gives us this. And if I graph that, let's see, mode, I want to be in polar, I am, so I go to y equals, and I do 2 minus cosine 7 theta, and there it is. Okay? Now it says determine, without an E, the norm. That's just how long this is. The norm of this vector is how long it is. So that's the square root of 4 squared plus a -1, if you will, but you don't have to put the negative because it's going to, squaring it's going to make it positive, and we get 16 plus 1, 17. Determine a unit vector. Well, if this is the square root of 17 long, a little over 4 long, we have to shrink it down to 1 long to be a unit vector. So we take 4 divided by the square root of 17 in the I minus 1 over the square root of 17 in the j, and that's the unit vector. And finally, the last problem. Respectively means in that order. So u is this one, and v is this one. Now we're supposed to do two v's. So v looks like this. So if I do one and then just do another one right there, there's two v's. And now I got to do negative 3u. So if u goes this way, negative u would go that way, and so to keep the same angle, I'm going to have to go something like that and about the same size. 1, 2, 3. And so there's 2u minus 2v minus 3u's, and so I get the resultant to be that, starting there and going to there. And this is a picture of that resultant. And that's the test.